Hello all, welcome back for another video. This time the video will be on solving inequations. When solving regular equations, you have one solution or two solutions. But when solving inequations, you have a family of solutions, an infinite number of solutions. Where instead of an equal sign, you'll have these signs, greater than, less than, etc. Okay, we're familiar with these signs. Go to our starter. You can represent your solutions on a number line. Okay, this one means that the number is greater than 2. It's not equal to 2 because we have an open dot here on the 2. Here it is, x is greater than 2. On the second one, we have x is less than -1, but also equal to -1 because we have a solid dot. So x is less than or equal to -1. What's this one? Well, not only is x greater than 2, but it's also less than or equal to 5. So we put the x in the middle, sandwiching the x. X is greater than 2 and less than or equal to 5. The next one we have x is greater than or equal to -5 and less than or equal to 4. Try the last one. If you said greater than -3 and less than 0, that's the correct answer. Moving on. Let's go to the lesson. Okay. Here's a sentence. I'm thinking of a number, I double it, and then subtract 4. The answer is less than 18. What numbers could I be thinking of? There's going to be a lot of numbers, an infinite number of solutions here that you could be thinking of. And we can solve them exactly the same way as equations. So you rewrite the statement using algebra. I take a number, I double it. I subtract 4, and that is less than 18. Then we work our way backwards. We use BIDMAS in reverse. Instead of subtracting 4, we add 4 to both sides. Then our result will be 2x is less than 22. And after that, we divide by 2. It's multiplying by 2 here. We divide by 2 on both sides. We get x is less than 11. You just carry the inequality along with you, not doing anything. So any number that is less than 11 will fit our statement at the beginning. If I take, say, 10. 10 times 2, 20. 20 minus 4 is 16. Yes, the answer is less than 18. Any number less than 11 will work. Why don't you give this one a try? So, multiply it by 3 and subtract 6. The answer is less than 21. Did you say 3x minus 6 is less than 21? Then we solve the exact same way as before. First we add 6 to both sides. And we get 3x is less than 27. Then we simply divide out the 3. 27 divided by 3 is 9. Any number less than 9 will answer this question. Next. Here's an interesting one. I'm thinking of a number, multiply it by 2. The answer is less than 15 and is greater than 5. So, the number is doubled. It's less than 15. Right here, less than 15. But it's also greater than 5. Not only is the number doubled less than 15, it's also greater than 5. So, if 2x is greater than 5, that means 5 is less than 2x. Now we can combine the first and third statements. And we end up with 2x, it's greater than 5, but also less than 15. Now we can solve this the same way as before. The great thing about inequalities is you can actually divide all 3 sides by 2. We want to get x alone, we can divide all 3 sides. Can something have 3 sides? I guess it can in math. Divide by 2. 5 divided by 2, 2.5. 15 divided by 2 is 7.5. So this number line shows all the possible answers. Any number in between 2.5 and 7.5 will satisfy this problem. For example, 5 is in between them. 2 times 5 is 10. Yes, it's in between 5 and 15. Okay. Everyone pause the video and try this one. Okay. We need to write an inequality. The number, you multiply it by 3 and add 1. That's going to go in the middle. The answer is less than 49 and greater than 31. So it's greater than 31, 3x plus 1, and less than 49 or equal to. Now we solve the inequality just like before. We can add 1 to, we can subtract 1 in this case on all 3 sides. Okay? So we end up with 30 is less than 3x is less than or equal to 48. Now we divide each and every part by 3. We get 10 less than x is less than or equal to 16. 48 divided by 3 is 16. And again, we can show all the answers here on a number line. Any number that's greater than or 10, not equal to, and less than or equal to 16 will satisfy the inequality. Okay. Now let's spice it up a bit. These ones are a little bit more tricky to solve, but there's a nice strategy we can use to solve this when we have x in all 3 parts. The strategy we have to use is this. We have to split it up into 2 separate inequalities, solve both, and then stick them back together again. So first we're going to deal with this one. X plus 5 is less than 3x minus 1. We're only going to deal with that inequality first. Okay? We subtract x from both sides. When we have x on both sides of the equation, we have to get x on one side of the equation. We like to keep it positive, so let's subtract the smaller value of x. Okay? So we're going to subtract x from both sides. We end up with 5 is less than 2x minus 1. We've taken away x from 3x. Then, same as before, add 1. 6 is less than 2x. And lastly, divide by 2. So, x is greater than 3. Okay, we've got x on the right, but x is greater than 3. Anything bigger than x will satisfy the first inequality. Now we're going to deal with the second one over here, 3x minus 1 and 2x plus 11. This one. We're going to do 3x minus 1 is less than 2x plus 11. Now we need to solve this one. Just like before, we want to keep the x's positive, so let's bring the 2x and subtract it on the left side. We subtract 2x from both sides, and we end up with x minus 1 is less than 11. And then we simply add 1. So x is less than 12. Now we've got 2 halves of an inequality. Okay? So we're going to sandwich these together. And we're going to see that x is greater than 3 and less than 12. And that's how you can do inequalities when you have x in all 3 sides. Pause the video and try this one on your own. Okay. Let's deal with the first one. I'm going to cover up this inequality here. We're not going to do that one yet. Let's just deal with this inequality. 3x is less than 6x minus 9. So we want to keep the x's positive, okay? So let's bring the 3x over on this side. We're going to subtract 3x on both sides. So we end up with 0 is less than 3x minus 9. Then add 9 to both sides. 9 is less than 3x. Divide out the 3. So again, we have x is greater than 3. That's the first one. Now here, let's cover up this 3x, and let's do the second half, this one. We have to subtract 5x from both sides, so we keep the x's positive. Okay, let's subtract 5x on both sides. We end up with 1x minus 9 is less than 1. This is not something you'd normally write in math. The 1 is not necessary, but we'll just carry it down for visual purposes. Now we add 9. 1x is less than 10. And again, now we don't need that 1x. So let's get rid of it. It's just x is less than 10. So we have to sandwich our 2 together, back together. We get X is greater than 3, but less than 10. Okay, let's go back. So, that was solving inequations. Okay? All the different possibilities. Let's have a look at the exercise now. Okay. Pause the video and try these ones on your own. And here's the answers. Now for question 2. Try these ones. Pause the video. And here's the answers. Thank you very much for watching, and see you next time.